Have you ever really stopped to think about what a modern car's nervous system looks like? I mean, we see the cool paint and the sleek lines, but underneath all that, there's a hidden world. We're talking about thousands of wires connecting dozens of tiny computers. And that complexity, it eventually hit a wall, a real breaking point, forcing engineers to completely rethink how a car is wired. So let's pull back the curtain and see exactly how they did it. All right, first up, the wiring nightmare. Yeah, to really get why this revolution had to happen, we've got to go back, way back, before the 1990s to see the engineering crisis that basically started this whole thing. So check this out. This is how they used to do it. It's a method called point-to-point wiring. And a good way to think about it is like this. Every little electronic brain in the car, what we call an ECU, that needed to talk to another one, had its very own private telephone line. So the engine controller had a dedicated wire to the transmission controller, the door module had its own wire to the window switch. You get the idea. It seems simple and direct, right? Well, yeah, that super simple approach works just fine when you only have a handful of electronics. But what happens when you start adding all the features that we just expect in a car today? Things like anti-lock brakes, airbags, power seats, cruise control, fancy climate systems. Every single new feature adds another computer, and that computer needs to talk to all the others. All of a sudden, you have a complete explosion of wires. The main wiring harness becomes this massive, heavy thing, which is terrible for fuel efficiency. It gets incredibly expensive, not just because of all the copper wire, but because of the sheer labor it took to assemble it. And the complexity? Oh, it became an absolute nightmare for manufacturing. And forget about trying to troubleshoot a problem. It was nearly impossible. What this all led to was a literal rat's nest of copper, just tangled all throughout the car. It was heavy, it was expensive, and it was totally unsustainable. You couldn't keep building cars this way. A change wasn't just a good idea, it was completely inevitable. So how in the world did automotive engineers solve this wiring nightmare? Well, they didn't just find a tidier way to organize the wires. No, they threw out the entire concept and replaced it with something way more elegant, a digital highway. And just look at the difference. It's truly night and day. We went from this complex, heavy, totally inflexible system to one that is simple, lightweight, way cheaper, and incredibly easy to expand. This was the giant leap forward that made the modern, feature-packed cars we drive today even possible. So what was the brilliant solution? Get rid of the hundreds and hundreds of individual wires. Instead, most of the car's components are now connected to a single, shared communication line. And this line is called a bus. So what is a bus system, really? Well, you can think of it as just a shared pathway for data. All the different electronic modules can send and receive their messages on this one common line. They're all listening, but they only pay attention to the messages that are actually for them, and they just ignore the rest. It's kind of like listening for someone to call your name in a really crowded room. Here is the absolute best way to picture this. The old point-to-point method was like trying to build a city where every single house had its own private road to every other house it might ever want to visit. Can you imagine the chaos? It'd be an absolute mess. The bus system, on the other hand, is like building one big, shared, efficient public highway system. Everybody uses the same road, but it's organized and it gets the job done using just a fraction of the infrastructure. Okay, so building a digital highway was clearly the answer. But you know how it is in engineering, solving one problem just leads to the next question. And in this case, it was, how many lanes should this highway have? Or in wiring terms, should our bus use one signal wire or two? And this right here is a classic engineering trade-off. You can't have it all. A single-wire bus is obviously cheaper. You're using less copper, the connections are simpler, but, and this is a big but, it's way more vulnerable to electrical interference, or what engineers call noise. That noise limits how fast you can reliably send your data. Now, a two-wire bus costs a bit more, but it gives you much, much better immunity to all that noise, and that allows for way higher data speeds. So what this really means is there's no single best answer. The choice depends entirely on what the bus needs to do. For something simple, like controlling your power windows, where speed isn't a huge deal, a cheap single-wire bus is perfect. But for the critical data coming from your anti-lock brakes, yeah, for that, you absolutely need the speed and the rock-solid reliability you can only get from a two-wire system. And that whole idea, choosing the right tool for the right job, brings us to the modern car, which doesn't just have one bus. No, it has a whole hierarchy of different networks, and each one is perfectly optimized for its specific task. Just take a look at this chart. It lays out the entire hierarchy perfectly. Down at the bottom, you've got your low-cost, low-speed networks. As you start moving up the pyramid, the data rate, the complexity, and, you guessed it, the cost, all go up. It is a really beautiful example of engineers applying that right tool for the right job principle across the entire vehicle. So let's take a quick tour using our highway analogy. Think of the Lin bus as your local neighborhood street. It's slow, it's cheap, and it's perfect for simple jobs like moving your mirrors or seats. Then you have the CAN bus. That's the main city freeway, the real workhorse of the car, handling all the crucial chatter between the engine and the chassis. FlexRay? That's your high-security express lane. It's faster, more reliable, and it's used for vital safety systems like steering and brakes. And finally, Automotive Ethernet. That is the brand new superhighway built to handle the insane amounts of data from your high-res displays, cameras, and all those advanced driver assistance systems. So what you get when you put all these different networks together is something called a domain-based architecture. It's just a smart way of organizing the car's electronics into logical groups, almost like departments in a company. You have the powertrain department, the safety department, infotainment, and so on, each with its own special network, and they all talk to each other through central gateways. Okay, let's boil this all down. What are the key takeaways here? Number 1, the old way of wiring cars with wire for everything created an unsustainable rat's nest as cars got more advanced. Number 2, the elegant solution was the bus system, a shared digital highway that simplified everything. And number 3, today's cars don't use just one bus, they use a whole family of them, a carefully selected mix of networks, each one optimized for its specific job. So we've seen this incredible evolution from a tangled mess of copper to a sophisticated internal internet. But here's the thing, with autonomous driving right around the corner and cars that are basically becoming data centers on wheels, the demand for data is about to explode. And that leaves us with one last fascinating question. How will this information highway have to evolve next to handle the traffic of the future?